Okay, so today I'm going to be talking about complex numbers. The square root of a negative number gives you an imaginary number or a complex number. Here's the definition that we're going to use. The square root of negative 1 equals I. Okay, so we can also say I squared is negative 1, because remember, when you square a square root, you just get the inside. So we have these two little definitions. We're going to build on that later. Okay. So right now the basics. Say we had the square root of negative 16. Well, the square root of 16 is 4. So the square root of negative 16 is going to be 4i. This one's a little bit harder because we have the square root of negative 120. Well, 120 is not a perfect square, so we have to think of something that can go into 120. And as of right now, I know 4 goes into 120, so we can split this up into negative 4 times 30. And then we can think of our list of perfect squares that might go into 30. So we have 4, 9, 16, 25. No, none of them do. So this is right. So we could take this part out, the square root of negative 4. Well, the square root of 4 is 2, so that is 2i. And we'll leave the 30 on the inside because you can't do anything with it. When you're multiplying these things, you have to convert them into i's first. Okay, so square root of negative 3 times square root of negative 8. We're going to have to say this is the square root, well, I times the square root of 3. 8 can be broken up into 4 times 2, or negative 4 times 2. Okay, so we can take this part out, and we'll leave the 2 in. So we have times 2i comes from the negative 4, and then square root of 2 is left. And then we can get our answer from that. So the answer for this one, remember, I times I is I squared, which is negative 1. So we have negative 2 square root of 2. So that's number 2. A little bit more complicated than we needed, but. So it really just comes down to, if you take the square root of a negative number, you turn the negative into the I. And then sometimes it won't be perfect, so you might still have some left. But if you have negative in, take it out, and it becomes I. So like here, we have 5 minus 2i, because the square root of negative 4 is 2i, times 2 plus 3 times the square root of negative 49 is 7i. So we could say times 7i. So we're going to have to FOIL this, but we can simplify this part first. This is 5 minus 2i times 2 plus 21i. So then we FOIL. We have 5 times 2 is 10. 5 times 21i is plus 105i. Negative 2i times 2 is negative 4i. And then negative 2i times 21i, that's where I squared comes in. So we get negative 41i squared. We'd add like terms. It's 105 minus 4i. So we could say equals 10. 105 minus 4 is plus 101i. And then we have negative 41 times I squared. But remember, this is negative 41 times negative 1. So that's 2 negatives make a positive 41. And we have 2 more like terms to add together. So we have our final answer here, if we combine these like terms, of 51 plus 101i. So this gets a little bit easier really, once you understand this definition, I squared equals negative 1. So here, if we FOIL, we have 3 times negative 2 is negative 6. 3 times 3i is plus 9i. 4i times negative 2 is negative 8i. And then 4i times 3i is plus 12i squared. So we can combine these. We get negative 6. 9 minus 8 is 1, so plus 1i, or just I. Now we have 12 times negative 1. I'll write this out this time. Plus 12 times negative 1. So that's 6, negative 6, plus I minus 12. And then add our two last like terms, these two. That's negative 18 plus I. It's going to be our final answer. So you can mix x's in with this. So for this one, same process though. We have x times x is x squared. X times negative 8i is negative 8ix. Kind of just sticking it all together. 8i times x is plus 8ix. So if you notice, these two things are conjugates, right? When you have the same thing except different signs, your middle terms always cancel out with conjugates. So those are opposites, they cancel. Then 8i times negative 8i is negative 64i squared. And then we get something we used to not be able to factor. We get x squared. Negative 64 times negative 1 is positive 64. So if you remember, we couldn't factor these things. Well, now you kind of can, okay? It's the same. If it was x squared minus 64, it'd be x plus 8, x minus 8. Well, now it's x squared plus 64, which we couldn't factor before, but now we can say x plus 8i and x minus 8i. That turns that negative that we used to have into a positive. Then the last one. So we have to write this out twice. 5 minus 7i times itself. And FOIL. Alright, so 5 times 5 is 25. 5 times negative 7 is negative 35i. Then the insides, negative 7i times 5 is negative 35i. And then negative 7i times itself is positive 49i squared. We add like terms. That's these two. We can say this is going to be at negative 49 because we have 49 times negative 1. And then we'll add these two like terms. So we get negative 24, which is 25 minus 49. And then negative 70 is what those combine to. So 70i. Alright, so now I'm going to talk about powers of I, because you can have I to several different powers, whatever you want. But here's how they work, right? So we know our definition, square root of negative 1 equals I, right? So we can say, okay, square root of negative 1 equals I to the first power, which is just I. We also know the second one. Because if we square this, we just get -1. We get the inside. So I squared is -1. Then we can develop what I cubed is. Well, I cubed is just I to the first times I squared, which is I times -1 or -I. And then I to the fourth is I squared times I squared, which is -1 times -1, which is +1. And then this becomes a cycle. I to the 5th power is I. I to the 6th power is I squared. I to the 7th power is the same as I cubed, which is -I. I to the 8th power is 1 again. Okay, so we can kind of develop this. Example, I to the 10th power. Here's a trick when you're dealing with these. Take 10 divided by 2, or 4. I'm sorry. There are 4 different answers here. So we divide by 4. We get 2 remainder 2. Okay, the first number here actually doesn't matter. We don't need it. The remainder is what's important. Okay, so the remainder is 2. So this is equal to I squared. You have to understand remainders, though, to understand this. And I squared is -1. Definition. Okay, so we had I to the 31st. 31 divided by 4 is 7, because 4 goes into 28, remainder 3. So this is equivalent to I cubed. And by definition, I cubed is -1. -I, I'm sorry, -I. I to the 77th. Okay, so 77 divided by 4 is 19 remainder 1. So this is equivalent to I to the 1st power. We don't really need to write the 1. It's just equal to I. So you see, these aren't bad. Just divide by 4, take your remainder, and make it your new exponent. If it's divisible by 4, so say this was perfect, the answer would be 1. They can make these a little bit harder, right? By putting multiple into one equation. So we can reduce this down now. 4 goes into 103, well, it goes into 100, so there's a remainder of 3. 4 goes into 20, but we keep this 4. It's just a multiplier, so we multiply. The remainder here, since 4 goes into 20, is 2. So that's I squared. Plus, this is I to the 1st power. This is -I. Minus 4 times -1. Because I squared is -1. Plus I. If we add like terms, we just get, well, these cancel. So we get -4 times -1 is our answer of +4. So that's powers of I. Now there is something called the complex conjugate, all right? When there's single terms, what we're trying to do is get the i's out of the bottom. This is just like rationalizing. So we're trying to get I out of the denominator because it is not proper, for some reason, to have I in the denominator. And we do it the same way that we deal with square roots and cube roots. If you have I in the bottom, you multiply by I. And it'll cancel itself out. We get 4I divided by 2I squared. So that's remember this is negative 1. So we have 4i divided by negative 2, and that divides perfectly, so our answer is negative 2i. If we divide 4 divided by negative 2 is negative 2. Leave the I. Same case, even a little bit easier because there's no reducing. Times I, we get 8i divided by 7i squared. That produces a negative 1, so we can pull that out front. As a negative, 8i divided by 7. And this one can get a little bit complicated, because in the same case with rationalizing radicals with two things in the bottom, we have to multiply by the conjugate. Okay, that's hence the section title. The conjugate is 1 plus 4i. And remember, we're only really concerned about the bottom. Yes, we still have to multiply it with the top to be, not break any math rules. Because really what we're doing is we're multiplying this thing by 1. We're not changing anything, we're just making it all look different. So we got a FOIL twice here, and that's where it gets a little bad. It's not too hard. So we have 2 times 1 is 2, doing the top. 2 times 4i is plus 8i. 3i times 1 is plus 3i. And 3i times 4i is plus 12i squared. And the bottom, 1 times 1 is 1. 1 times 4i is plus 4i. Negative 4i times 1 is negative 4i. And negative 4i times positive 4i is negative 16i squared. We add like terms, so these two and these two. These cancel, and they have to because otherwise you did something wrong. Because there shouldn't be any i's left in the bottom once you're done with this. So we have, well, let's write this out one more time first. So we have 2, those make 11i. 12 times I squared is 12 times negative 1 is negative 12. 1, negative 16 times negative 1 is positive 16. So we get 1 plus 16 on the bottom. We'll add like terms and finish. So our final answer, 2 minus 12 is negative 10 plus 11i over 1 plus 16 is 17. Note, if you can divide something out of all three of these, then you can keep going. But 10, 11, and 17 have nothing in common, so you'd stop there. That's it for today.